Good afternoon, everybody. So welcome to Decarbonising Our Cities, Building Tall with Timber. This is a presentation from the TTF and part of the launch of the manifesto for Wood Equals Hope. So I'm just going to give you a brief introduction to what we're talking about. I'm Andrew Waugh from Waugh Thistleton Architects. We're a practice that are passionate about timber construction for the last 20 years. We are a practice driven by purpose and by ethos, more than profit or growth. So we very much believe in what we talk about and believe in the work that we do. So talking about embodied carbon, which is really what we're here to do, really the underlying reason that we're using timber. So the global carbon emissions that we have from transport, from energy, from all the different energy uses around the world, about 11% of those global carbon emissions are down to construction's embodied carbon. So that's the material manufacturing, the transportation, the construction, and the end of life of those building materials. So that's a major contribution that is directly affected by the choices that architects, engineers, design consultants, in fact, the whole construction industry are making on a daily basis. Now, we know that at the moment, primarily across the Western world, the carbon of buildings is measured through their operational carbon. And yet we know over time that actually, as we get better at generating our energy from renewable sources, we realize that actually embodied carbon is going to be an increasingly serious issue from where we are at the moment. So that 11% will very quickly grow exponentially unless we do something serious about it. Now, we know as construction professionals the kind of responsibility that we have individually or collectively. Now, this is thanks to Chris Wise from the engineer for these figures, but this is pretty much applicable to architects as well as engineers. I don't want to put Kelly completely on the spot for here, but going vegan for each one of us consultants will save around 2 tons a year, reducing our carbon footprint by 2 tons a year. And yet we're responsible, an engineer typically responsible for around 2,000 tons of carbon a year. Now, by making a 10% saving in the carbon emissions of the embodied carbon of your designs, you can make 100 times. You can make an engineer 100 times more vegan. You can make 100 engineers vegan by doing that, and in fact save more than 200 return flights to New York. So these are really direct issues that design consultants, people involved in the construction industry, can immediately have. Now, we know that actually the best way of doing that is to build nothing, to explore the alternatives, to think about how we can regenerate and refurbish existing buildings, and building less, so maximizing the use of the existing building materials and the buildings that we have. And then by building clever, so optimizing the material usage and designing with low carbon bio-based materials and building efficiently, so using low carbon construction processes, technologies, and eliminating waste wherever possible. So we know that actually we can be clever and be smart about these reductions. Now, for us as a practice, that started in 2008 when we built Murray Grove, a 9-story timber building, which was a wonderful, exciting process. 27 days we completed, 4 people completed the entire structure in 27 days, and it was a very clean, lightweight, quiet process. And the building's still there now, sitting beautifully in Shoreditch. And so there's been quite a history since then. So since 2008, when we built this 9-story building, we've now doubled, more than doubled actually, even since I put this slide together a couple of years ago. But we've more than doubled now the story heights. So looking at now in 2019 with Nguyen Starteret, forgive me any Norwegians out there, but which was 18 stories, but now of course we have buildings in Sweden of 25 and more across the United States being planned, and in Sweden, Scandinavia, and Switzerland. So really exciting, exponential history. But I think important to sort of say a word of caution here about building super tall buildings. So this is the greenhouse gas emissions per household in New York. And so we can see in Manhattan, where the taller the buildings are, the greater the emissions per household are. So we know that tall buildings are not terribly efficient in terms of operational carbon. And similarly, in terms of embodied carbon, so the number of stories across the bottom that it takes to actually the volume of foundations and the emissions from those as we go up, we know there are sweet spots for construction in terms of carbon emissions, which hover around the sort of 12 to sort of 18 story spot. And we can also see that in terms of the energy use, the operational carbon versus the building height. So single family houses, the worst culprits per household. But actually you can see this kind of, as the U value goes back up here, that actually towards 40 stories, and we're creeping back up so that our operational emissions per household begin to creep up. So because this whole narrative, because this whole exercise is based on reducing carbon, we also need to be clear about that the underlying principle of what we do is about reducing carbon. Now, we know that in places like New York, where the average age of an office building in New York is over 60 years old, and this is becoming fast redundant. And yet, carbon-wise, we can't take these buildings down, demolish them, and rebuild them in place. This is an existing embodied carbon store that we have here that we need to retain. So how we can extend these buildings, how we can increase the floor plates of these buildings using the existing foundations and the existing service runs of these buildings, I think is a really exciting future for timber. And on that note, I would like to introduce Paul Brannon, live and direct and cold, by the look of it, from COP, from Glasgow. Thank you very much, everybody. And thanks, Paul.
Well, hello, Andrew. Hello, everyone. As Andrew says, this is coming to you live from the COP in Glasgow. I'm in the green zone, which is on the south side of the River Clyde, which is where the NGOs and some of the businesses are with their stalls and their message for COP. And behind me here is the main conference centre, which is called the Blue Zone, which is where the politicians and the decision makers and quite a lot of people from business and some NGOs are in there, where the actual negotiations are happening. I understood that the two sites were going to be linked by a footbridge. The footbridge is there, but it's closed actually. So it's a 20-minute walk for the politicians to get round to the green zone, which is a bit of a problem. I was at the COP in France, and it was much easier to move between the two zones. But the reason why I'm here, and I'm representing Cibois, which is the European woodworking industry, and EOS, which is the European sawmillers, is that we have worked with our European colleagues in the woodworking and sawmill and to some extent forestry industry since the beginning of the year at a European level, but we've also involved our Australian, New Zealand, Canadian and US colleagues in producing a manifesto for the COP. We felt that it would be a good idea to set out in a relatively short document our sort of key messages to deliver to the politicians in relation to the contribution, and it's a large contribution, that building in wood, both new build and renovation, could make towards tackling climate change. So we've produced this punchy document. It folds out, which is a design to try and give an idea of just how big we can now build in wood. As Andrew says, we've got some really quite tall buildings going up around the world. This is the tallest wooden building in the world at the moment, which is in Norway, which is 18 stories, and 24 stories are currently being built in Milwaukee in the USA. And one of the messages we wanted to get across to the politicians is that we think that they're very well aware that you can build 1- and 2-story houses, family homes from wood, and we've been doing that in North America and many parts of Europe and around the world for hundreds of years. But what's new is this ability to do high density building and tall buildings in wood. And from my experience talking to politicians at a European level, is that penny has not yet dropped. So part of what we wanted to do with the manifesto, which is called Growing Our Low Carbon Future, Time for Timber, what we wanted to do with this document was to convey that message to the politicians that we now can build high density, tall wooden buildings, highly suitable for city centres and urban areas. We're not just talking about building in the suburbs with wood anymore or in rural areas. This is for our cities. That's where most people in the world live, and that is the trend. So if you look at a country like Egypt, 100 million people in Egypt, and in a relatively short space of time, 50 years from now, there'll be 150 million people living in Egypt, and they will be predominantly in an urban setting. And if we're not careful, they'll be living in tall buildings made from concrete and steel and cement and all of the carbon emissions that go with it. So there's a huge opportunity here going forward. Somewhere roundabout at a European level, maybe 15% of the built environment is wood-based. We want to be doubling that by 2050. And when it comes to renovation, next to nothing's happening in wood or wood fibre at the moment. Again, a massive market. When we renovate our buildings, we mustn't just do it with the traditional materials. We've got to get a lot more wood in there. And that wood into those buildings is continuing to store carbon. It's stored carbon as it's been sequestered in the forest, but it goes on storing it in the built environment. And getting that message across to politicians is a key part of this document, is that wooden buildings can store carbon. It's a form of carbon capture and storage. The politicians are desperate for carbon capture and storage at scale to work. It already does work. It works in the form of wood stored in buildings. So getting that message across to the politicians. And at the same time as it's storing the carbon, it's substituting for other materials which have much, much higher emission rates, whether that's in renovation or new build. So the ability of wood, this wonderful world of wood, where we can sequester the carbon in the forests, we can then store it in the built environment for hundreds of years. We can store it. And then this ability to substitute. And it can all be done in a sustainable way. That's the other message that we've got in here, is that we can use sustainable forestry to provide us with this amazing building material. So that's what we've got. I was up last week circulating it. I'm back up today. I've met with some of the people who are here on the European Parliament delegation and passed on some copies that they will circulate to the wider delegation and take back to Brussels. And we'll go on getting that message across. Today's the day where there's a focus on the built environment and cities here at the COP, so it's particularly important that we get the message out today. And if there's anybody listening from an organization, you can support this. If you go to the World of Wood Festival online, there's the opportunity to add your logo, add your support, and this is a growing list. We're going to do a further print run where we'll add in the logos. So there's an opportunity for you to support this initiative as we aim to get across to the decision makers and the politicians that there's an absolutely key role for wood in helping to decarbonize the built environment. And if we don't decarbonize the built environment by 2050, then we cannot hit the net zero target. And building with wood and renovating with wood is a key way of doing it. So that's our message from the COP. I will now hand you back to Andrew in the studio in London.
Thanks, Paul. Next up, we have John from VHAG. Thanks very much, John.
All right. Thanks very much indeed, Andrew. The talk I'm going to do today really is to talk about VHAG's involvement in the world's tallest hybrid construction tower. I mean, VHAG are a long-established Austrian glulam manufacturer and subcontractor, and are well known in the UK for some iconic projects like the McKellen Distillery and the two Crossrail stations in London that we provided the roof structures for. But we've been making a name for ourselves around the globe, providing the glulam frame for multi-storey buildings, such as the 52-metre high 25 Kings in Brisbane, and the 40,000 square metre floor area ABS building at Singapore's NTU, and as well as the 10-storey redevelopment of the Import House in London. For projects in Europe, we normally do sort of detailed design, spline, install, but for projects further afield, we sort of normally do just design supply of the elements. Then that seems to be the most effective way of doing it. So this is the Ascent. It's a 25-storey new apartment block in Milwaukee, Wisconsin, and it'll be opening in July next year. It's got sort of 6 stories of RC, and then the concrete cores, and then 19 stories of glulam and CLT frame. And the image sort of neatly illustrates how hybrid structures often are the best solution, and that timber isn't appropriate for all applications. And really, it should just be sort of considered as part of the normal palette of materials to be used in a project. It's always a sort of balance between column centers and floor depth. With each project, you have to sort of look and see which is the best sort of combination. And in this instance, the column grid is between 5.1 and 6.1 meters, and 5.5 and 7.6 meters, and CLT spanning 5.1. So the one thing is to get across here that using timber doesn't mean having small column centers, reduced column centers, because obviously that's really important to the end clients. One of the sort of key drivers with this project was to showcase the mass timber by exposing as much of it as possible. And as you can see here, timber's naturally beautiful, and when it's indoors, it doesn't need any expensive cladding or coatings. And another driver was to offer like a low carbon solution to the client's customers. And really, the sort of, just with the glulam was 2,300 meter cube of sustainably sourced glulam, which captured around 1,900 tons of CO2. And that really goes a long way to meeting this aspiration. There's no permitted path in the regs for a timber building that exceed the height limit by nearly 200 feet. And it's interesting to contrast the pragmatic approach taken by the authorities when compared to that often encountered in the UK, as rather than just say that timber is a combustible material and cannot be used in the structure, they instead asked the team to robustly prove their design. And this lengthy process culminated in the glulam successfully passing a 3-hour fire test. It was carried out by the US Department of Agriculture's Forest Products Laboratory. And you can see there on the right there, the sort of charred remains are apparently going to be proudly displayed in the reception lobby area of the building. So that's sort of, just on the sort of subject of fire in UK construction, just a sort of few points to sort of consider. As sort of demonstrated here, non-combustible materials can still fail in a fire. You know, a blanket ban on materials will do little to make buildings any safer, and really legislation should be in the public interest and science-based rather than sort of knee-jerk and politically motivated. You know, the only thing that will make buildings safer is a change in the culture of UK construction industry, as rather than being generally collaborative, it is instead excessively contractual, with a race to the bottom on tender prices based on the illusion that low price equals best value. And this forces everyone involved to cut corners in all aspects of the design, supply and installation. Okay, I'll get back off my soapbox now and back to Ascend. It does seem strange that in a country with such a great heritage of timber construction like the US, that it should be buying the glulam and CLT from Europe. But whilst the US does have a large and established timber industry, it does not yet have the expertise or capacity for structure that is scale using glulam especially. So following an exhaustive tender process, the contract was awarded to Timberlab, who placed the supply glulam with VHAG, supplies CLT with KLH, and the installation with CD Smith. And really just to say that VHAG has supplied the product doesn't really sort of cover the scope of works which we did, as it involves sort of consulting and offering advice, technical feasibility and coordination, clarification on 3D models, which involved a lot of reoccurring tests on CAD-CAM interface, and preparing all CAD-CAM production drawings, including 3D models, and factory fixing all the connectors, and it included over 50 tons of connectors and fixings and countless screws. And we also provide the fire protection to the glulam elements, and our package included all the logistics, included planning, container, transport and shipping. So it's not just really a simple supply at all. You know, when you're sourcing from a European country for a project in the US, it's not without its challenges and considerations, what with various different industry standards and approaches between Europe and the US. But there was this willingness to collaborate by all parties that ensured that these were successfully overcome. And it's not to underestimate the sort of challenges in that. The project used European spruce graded to the highest standard, structural standard, GL32H, and so that meant that a total of 6,000 cubic meters of sawn timber had to be graded just to provide the 2,300 cube of glulam. And really the lesser grade timber wasn't chucked away, it was used on other projects that needed a lesser grade. And any wastes, sawdust and offcuts go into our biomass power station, which makes us self-sufficient on heat and electricity. So VHAG doesn't have any worries about gas prices on there. There's nearly 2,500 glulam members in our package, and they're really chunky elements. The columns are 420 by 420, up to 420 by just over a metre, and the beams were 440 by 760, so really chunky members on there. And you can get an idea, really, it's maximum prefabrication. This is all about off-site, and it uses very advanced CNC machinery, and all the connectors are factory fitted, and we fire taped all some of that fire taping there. And so when they came to site, they got very fast and safe installation. This sort of illustrates, really, unless it's a small aperture, any sort of large apertures need to be made in the factory, and they have structural implications. So really you've got to design it in, and so you've got to really think about M&E and things like that a lot earlier than you will with trad build on there. And you can see here we're putting coatings on in the factory, and that gives a very high quality finish rather than doing it on site. And in this case, it's an aqua varnish, and that helps protect the glulam during installation. Yeah, quality checks carried out all the way through the production process, as really there's no plan B when you're on a 7-week shipping time. So you have to get it right. And it does force you to make decisions earlier and really force you, you can't make it up as you go along on site. You can see the members all wrapped and stacked onto special timber sleds that we make, and that's great for easy loading. And we use 3D modeling to maximize each load and ensure it's stacked in the right order to minimize double handling. And then we use the sort of machines that you see down at the docks for loading the timber efficiently and safely into the containers, and that minimizes any damage as well. When it then gets to site, what we found is really important to use competent installers, and the teams on the Ascent project certainly are. And the timber structure on the project is going up about 1 story a week, including the CLT. And apparently they're using a quarter less workforce than would be used for the installation compared to an equivalent concrete structure. And also the total build time will be about 4 months less. So you can get an idea why people are using this type of product. It's not just about the sustainability side. The design is a post and beam construction with the columns being 1 story high. And you can see how discrete the connections we provide are with there. And you can note the temporary propping, and what's really important with that it doesn't fix to somewhere that's going to be seen when they're removed, because you can mark in. It's important to protect the structure during construction and really get it watertight as soon as you can. And you can see here they've left the polythene on around the columns, which is not something we'd normally do, but it's going to be taken off very shortly on there. Yeah, this type of off-site construction uses high tolerance products, and that means less snagging and no wet trades. And other trades like M&E can find their work much easier to fix things to than if it's an equivalent structure. You get an idea of how the timber looks in its natural state there, a very attractive appearance. Yeah, this project was a great example of collaborative working, bearing in mind that it has taken place during a time of incredible challenges, what with pandemics and ships getting stuck in the Suez Canal. And it really is a credit for everyone that's been involved in it. It's been a real pleasure from our side on there. And really, as the project nears completion, ready for its opening next year, it's interesting to reflect on how other countries are pushing ahead with multi-story timber builds, whereas the UK, after really leading the world for the last decade in pushing the boundaries with timber engineering, is now seems to be sliding back to traditional forms of construction for multi-story structures, despite the ongoing climate emergency. Anyway, that concludes my talk today. And
that was great. Thanks, John. That was absolutely fascinating. Absolutely fascinating. Thank you very much. I look forward to seeing it myself. So next we'll move on to Nick Milestone. Great to see you, Nick. And you need to unmute, Nick. You're as bad as me now, look.
I double touched it. Apologies. Can you hear me now? Perfect. Thank you. John, that was great. Andrew, thank you for the introduction. And yeah, thank you for giving me this chance to speak. Just need to make sure my video is working. It doesn't appear to want to. There we go. Yeah, we're good. Right, okay, let's get started. So thank you. So a little bit about me. I've been blessed in my career. I've been in construction 36 years. I've been involved in many major projects across the globe in mass timber, be it in North America, to Singapore, and predominantly here in the UK. And it's just a great journey. And what I'm seeing now is such a big demand for mass engineered timber products as we're addressing the global climate challenge effectively. So what I'm pretty passionate about is my own roadmap, which is about integrated digital delivery, DFMA, green and sustainable technologies, and above all else about construction disruption. And CLT especially has been the disruptor in the last 20 years, which has given us the option, the ability with BIM and offsite to start sort of engineering these sort of wonderful structures. You can see here there's very much steel and mass timber together. This is my foot in both camps, more because they are symbiotic. They are designed, manufactured and constructed within 2mm tolerances wherever on the planet. And that makes such a huge benefit. It allows us to use form and function across a variety of buildings, but it's the iconic buildings across the planet that are starting to achieve the global recognition, whether that's in office buildings in London, Oregon, or in Sydney, Australia, to residential towers in London, Vancouver, and Sydney, and even universities. They're often the start of a pioneering journey in any country. We're starting to see CLT especially become a very much used floor plate more so than walls. We're seeing that now with light timber frame in the US, CFS or light gauge steel here in the UK, and long span structures as well. Very much, and you'll see quite a few familiar buildings where structural steelwork is the obvious material of choice because of span depth reductions. We can go more open span using cellular beams for services integration and the like. And I'll just show this very briefly. Kelly's going to talk more about this. This is a project we're working on since Grenfell and the minimalisation of using combustible load-bearing materials vertically, internally and externally. It doesn't prevent us from using cross-laminated timber as a structural floor plate. And this is something we've developed. We can go up to 15 stories. And I think in the next 18 months, you'll start to see this rolling out more in the UK. So what I'm going to talk today is about the Nanyang Technical University in Singapore. For me, this is a very personal journey, spanning over 4 years. When I moved to Singapore in 2017, within a day of landing, I was in a meeting with RSP Architects and Toyota discussing this, and this effectively is a ground scraper. It's about a total net area about 45,000 square meters. It's 6 stories high. It's a simple beam and stick, and the client was insistent that he had the right people in the world to deliver it, which brought many, many challenges. And this is all from the DFMA handbook from the Building Construction Authority of Singapore, focused on mass engineered timber. So if we look at the structure, it's actually quite relatively simple. We've got 160 mils thick slab. In the majority of areas, we've got 525, 60 square glulam columns. You can't get any sweeter than that. But how do you shift nearly 14,000 cube of mass timber from Europe to Singapore logistically? So what we looked at was, okay, how do we scale it? And this goes back to 2019 in July, and we set ourselves these challenges. How are we going to scale structural design? the BIM modeling, the glulam, the CLT, the screws, the transportation, the logistics, the management in both Asia and Europe, and the site labour who's going to build it. And so Newcon, with the principal contractor, nominated to build the job. SteelTech, a subsidiary of John Seng Construction Group, was nominated to do the MET design and installation, and I was part of that journey. Then when we move forward a bit, sorry, I've just frozen again. Sorry, I just have to escape it. I think it's my Wi-Fi locally here. Here we go. So how do we scale up? Well, we had to look at who had the biggest design houses. Design and detailing, we looked at Urban here in London. We had to split the model up, it was that big. So we used Urban from London and CAD makers from Vancouver. We worked with VHAG to manufacture and deliver 6,100 metre cube of glulam. We worked with Stora Enso to produce the 46,000 square metre or 7,500 cube of CLT. Screw-wise, we had 1.1 million screws on the projects, procured with Rotoblas in Italy, but actually came from Taiwan. And above all else, the transportation and logistics was managing 478 containers, each containing around 45 cube of material. So we had to put in an extra 6 to 10 weeks in the procurement program. The management team, we had Gary Caulfield from New Zealand, John Byrne from Great Britain, Dave Kingham, great guy, Kiwi structural engineer who's currently in Europe but was in Singapore, and then myself. We had to procure approximately 60 guys on site. So we went around the world. We went to Savcon in Australia, Woodtech from Taiwan, and we used local labour from both Steel Alley and SteelTech. But then what we didn't estimate was this bigger issue, the bigger issue called COVID. And that was pretty much causing us a problem. Effectively, we should have started on site in March 2020 when lockdown happened. That was deferred to October 2020. The general contractor just wasn't ready. And with the impact of COVID, and on the first, second, and third wave, impacted the production lines at both Stora Enso, at both VHAG, and that had an impact. And that effectively took us from a 26-week, which was planned, to an actual 52-week program. So it had its challenges. But when we look at this was the first mock-up we did back in mid-July 2019. And this was just one small box. And we just realized the sheer scale and size, because we were not just doing whitewood spruce, we were doing larch as well as the fins. And that's what really sort of put the enormity on the project. So we modeled it in VDC, full BIM model. And that took us to absolute detail where everything was counted for. We knew exactly where every screw was going, how the interface is going. We actually did the headset walkthrough, and we did both augmented reality for the client, so we could walk through the details. It was just so important, and how advanced BIM was to allow us to do this. But then we had the sort of the realization of taking the materials from Austria all the way to Singapore. If nobody's familiar where Singapore is, it's the southernmost point of continental Asia. And here's a map of Singapore. And I show this map because I know Dave Kingham will be watching this. And what you can see there is the rain radar. And it rained over Western Singapore where the project is. And it rained. And I will come back to the rain because that is a serious factor. So here we are in VHAG's facility doing our glulam columns, and this is the CLT coming from Stora Enso, and we had some seriously huge storage facilities. Thankfully, John Seng had their own integrated storage depot in Singapore, so they unloaded the containers for us, and we had the materials in, well, pretty much sometimes finding a needle in a haystack. You see in the bottom right, there's John Byrne. He's a very experienced mass timber erector from the UK, and this is crazy Dave Kingham. And without Dave, we wouldn't have got through this project. And Dave just lived and breathed this project 24 hours a day, and he was an absolute key to the success. Some phenomenal innovations came out of this. And I show this one specifically. These are proprietary connections. We decided to get away from traditional thin plates and through bolts, and get away from ugly connections and encapsulating those bolted connections to use proprietary connections, and they just slotted into place. Yes, we had to put tension plates on top, but it absolutely made a difference to the speed of construction. We kept the beams and columns wrapped as much as we could because of the high UV in Singapore, though it had both a UV and a termite coating on. And the project, wow, it was just phenomenal at scale and size. And we kept the wraps on as much as we could, as long as we could. That was absolutely so important. And here we are, it's just starting to take shape. It's built around 6 concrete cores. It's a lovely integration of concrete and timber working together, despite the tolerances of precast concrete. Here you can see on the left some of the guys on the lecture theatre floor mixed in with some structural steelwork. But you're starting to see how the larch exposed, and we were very much against having materials used in a class 3 environment because of the rain, because of the sunlight. But they've got 4 coatings of UV, which will have to be maintained over the years, but it was there, so we use larch, so it wouldn't degrade as quick as what whitewood spruce would. And it's starting to take shape. This was probably around March 2021, and we're starting to build it. We're building the lectures, but you can start to see the connection free in the columns to the beams. And this is what really sort of captures the eyes, that it's not as industrial as once it was going to be anticipated. Similar picture what John showed, 3-story height columns coming through, but it was just an endless forest of columns and beams, and very symmetrical, very set out, and actually very straightforward to install. And it actually went incredibly quick. And we kept the wrappings on as much as we could because we were dealing with a new client, a new industry, which is not familiar with mass timber, and people would just treat it like steel or concrete. Well, it is the finished article. We have to treat it like furniture. And it went up, and it went up exceptionally well. And boy, did we have some screws on the project. Even halfway through the project, we tried to value engineer it just to remove the number of screws. It was more based on the diaphragm and the vibration action between the CLT and the glue lamp relationship. And we went through a lot of tape as well for rainwater management. What did we do when we look back from it? The locals, they fell in love with wood. We taught them to love wood. We taught them how to look after the wood in repairs going forward. We did some great stuff with edge protection. We made it safe. I mentioned the rain, and there's the rain. It rained. Singapore endured its worst rainfall in 42 years. And this is a country that rains a lot and doesn't have a rain. It has a tropical downpour. And wow, we must have spent as much time with the labour just absolutely just keeping it dry. And yeah, did I mention the screws? There was a lot of screws. It was challenging. Gary, who I mentioned, very sadly, tragically passed away just before it started construction. So we had a fallen hero, and we very much remember Gary for this job. And this is where people like the characters stepped up to the mark, like Dave King. And without these people, we've never got these jobs built. So we kept focused with Marla, our QS, John on site, myself here in the UK, managing the European side of life, and Dave. And last week was the installation of the last panel, and it was an absolute success and testament for the 52 weeks for all those guys who lived and breathed it. And we tried to get some really good images of how it looks, and because the building is just so big and there's just not a great angle to sort of pick it up, but you can see the enormity and the scale of the task that went on to build what is classed as Asia's largest timber building. When you look at the sheer volume, it's the world's largest timber building of single use. And this slide is so important because we went through everything. And Dave King subbed it up beautifully. We had COVID-infected ships which docked off at Sri Lanka. We had the weather in Singapore. We had labour issues caused by COVID outbreaks. We had issues with concrete tolerances. We had the local authorities like the BCA questioning everything we did. We had a lot of snap screws and a lot in 1.1 million, constant material checks, questions from the client who wasn't familiar with it. And yes, we even had the stuck ship in the Suez Canal, and we had 17 boats floating around the Mediterranean with all our materials on, wondering how we get there. But we got there, and it was an absolute result. So it's just been great. I won't go too much onto this because Paul Brannon launched it earlier in this conversation. This is so important. This is the policy And these are the 5 policy recommendations that we've gone around the world, from North America to Australia to Japan to Asia to the entire of Europe and Latin America, how we can encourage world governments and economies to have a timber first policy, because the amount of wood we've used on the NCU has effectively saved 27,500 tonnes of CO2 in the material that's sequestered and stored in the wood itself, and the amount it would save against a traditional steel and concrete structure. That pretty much concludes my speech. I hope you enjoyed what has been a 4-year journey.
Thanks, Nick. That was a really inspiring journey that you've been on, and thanks for all that hard work. I think it's shown real leadership, so really impressive project. So next, Kelly. Thanks very much, Kelly Harrison of Whitby Wood. I'll leave you to introduce yourself, and look forward to this. Thank you very much, Kelly.
Thanks, Andrew. What an impressive project, Nick. 1.1 million screws. I still can't really get my head around that. I'll be thinking about it for a while, I think. So hello everybody. I am Kelly Harrison. I'm a structural engineer and I work at Whitby Wood. We are based in London. We're based in the UK, but we have projects. We have an office in India as well, and we have projects across the globe. But today I think we've seen examples of tall projects in the US and what did Nick call it now? A ground scraper in Singapore. But I thought we'd touch a little bit on how we build tall in the UK, or can we build tall in the UK? I think everyone is familiar with the disaster that was Grenfell in London back in 2017 now, and that really changed the environment for timber construction in the UK. It created a lot of nervousness in the industry, a lot of questions about our approaches, rightly so, and it's made a lot of people and a lot of consultants and a lot of suppliers go and do extra testing, look at new ways of proving the fire capabilities of our mass timber structures, and it's been a real journey. But it does mean that there's a lot of nervousness in terms of approved inspectors, in terms of clients, and mostly the barrier is insurance for those clients. But there's a real will, because of all of the embodied carbon reasons that Andrew mentioned earlier, from designers and clients and end users and tenants of these buildings, for us to be using low embodied carbon products to build them with. And so we're really seeing a lot, and we've got a lot of timber projects on the drawing board at the moment, but the number of them that are actually built is less than it was back in sort of the early 2010s. I think Andrew Murray Grove is probably one of the tallest timber buildings in the UK, and John Spittle's Anchorage House at Republic is probably 10 stories in terms of a commercial refurbishment project, one of the tallest. And so I'll just show you a few now of what we've built recently. We're nowhere near those heights in London, but this is over at the Greenwich Design District, which is near the O2 Centre. There's a series of buildings there, and they were built by lots of different architects. I think there were 8 different architects involved, and I think there was one architect in particular, Mole, who insisted that their buildings, I think each of them designed 1 or 2 buildings each, were made from timber. And it's interesting, having spoken to a few of the different architects and the client, that perhaps if this development had been conceived currently rather than back a few years ago, a lot more of these buildings would potentially be timber compared to what was actually built. But there were some really lovely shapes, there's some really lovely moments, and really, they're really beautiful buildings, I think. And having gone to the opening and seen a dance performance in this space a few weeks ago, it was really, really lovely to be in there. But this is what we're building at the moment. There are some more projects. Andrew Waugh's got a fantastic one in Shoreditch, a 6-story LVL and glulam and CLT building. So we're going up to 6 stories. But what can we do? And where can we go? So we've been looking with Walter Sutton Architects at a couple of projects recently where we've been really trying to get residential buildings, find a solution for residential buildings post the ban on combustible materials in the facade over 18 metres, and seeing how we can still use mass timber effectively in those. So first off, here's just a quick example of how we would have built CLT pre-Grenfell, and that would have been with CLT walls, floors stacked on top of each other. All of the walls were load bearing. And then would you first off think, how do I remove the combustible material from the facade? And so perhaps you would put a steel facade around the edge, and that could be a light gauge steel frame or a hot rolled one as it needed to be for the geometry or the height. But then we're looking at this and we're just thinking it's so much material and it's lots of different trades and there's construction sequence issues and there's lots of details and it gets expensive. And we can do it. And it could be the right option for certain building layouts and certain situations. You think we could probably go up to 8 or 9 stories with this, and it's a nice solution, but I think it would turn out to be quite an expensive one. Nick Milestone, he alluded earlier to this solution that he's been developing at SIGMAT. We at Whitby Wood, historically, the engineers there have done a lot of residential projects and reinforced concrete residential projects. And they've seen a big turnaround with the materials market and changing recently. And a lot of contractors now want to do light gauge steel framing rather than RC wherever possible. And so I really like this idea that we can go with the light gauge steel framing. We get our walls already built. And it's the same system as a CLT really, but your exterior wall plus all your interior walls are non-combustible. But by using the CLT slab, you're reducing the weight and you're reducing the loads, therefore any transfer decks or podium slabs that you might have, and on the foundations below as well. We've been looking into the embodied carbon numbers, the sequestration, and then figuring out all these details and how they might work for disproportionate collapse, for fire situations, and where we might have to hang balconies off and support facade work, brickwork, etc. as well. And I think it's a really interesting solution, but as Nick mentioned earlier, it goes up to about 15 stories. Before the loads would be too high in terms of vertical and wind loads on the metal stud walls. But it's nice to think that, you know, a CLT could really start to make an impact on the solution. At the moment, this would be built with a metal deck slab, which is obviously a wet trade. You have to wait for it to go off before doing the next floor. I think we're talking about some serious program benefits as well, keeping it all dry and taking the wet trade off the critical path. But then we're thinking, what happens when you go taller than 15 stories, and what can we do there? And being involved myself, not only at Whitby Wood as a structural engineer, but also I used to be a director of TRADA with Nick, and now have moved to Timber Development UK. And you get exposure to lots of projects all over the world, and listening to webinars like these today, a lot over the last few years. It became across Brock's Common, for example, in Canada. We've got an 18-story building there, and it's got no beams, it's a flat slab. And in that building, the columns are at really close centres because they're supporting the corners of each panel. But we found, speaking to Rotherblast, we found they've got a new connector, which we'll show a bit more on the next slide, which does mean that we can actually start to increase that and get a two-way CLT solution to work with columns at bigger centres. So here, like similar to the grid sizes that John was alluding to earlier, we could look at something like a 5.5. I think they go up to 7 meters, but if you want a really efficient system, you might want to base it on a standard panel size. So we found a 5.5 meter grid in one direction at least worked very well for setting out the building and setting out the panels and the columns, and getting a flat slab CLT solution to work. And that worked by working the different layers working in different directions. It works in the same way as an RC slab in that manner. And then there are connector plates glued in between the panel breaks, which transfer the forces through to the next panel. And this gives us, we were looking at the zones it gave us, and it was very similar to a concrete slab solution. And so we thought this is a way forward. We explored using timber columns with it. They got quite big at the bottom, so we thought a hybrid steel column was potentially the right solution, but also we're keeping our timber out of the facade. And so we had to have some hot rolled elements in our facade because of over 15 stories, your light gauge is no longer able to be load bearing. And we started thinking about this, and if we're going to have all this steel in the facade, how can we make the most of it, and how can we make it work to its best ability? And actually using the facade system that we developed and adding some very light cross bracing and in certain elements on certain elevations meant that we could get our stability from the facade steel and then not actually rely on a concrete core at all. And so that meant we might have more flexibility in our core if there was ever a change of use, or there were new technologies in the future that you wanted to thread through the building somehow. And also we looked at that against building a concrete core and adding more steel into the facade, and found that it had less embodied carbon as a solution. So we thought that was quite exciting. We then dug into lots of buildability issues. How do we prop things? How do we get the right edge protection? It looks like Nick had some great solutions to that on his Singapore project. We were thinking here that maybe we could be installing the facade in horizontal panels that were 1.5 meters above the slab level, and provided your edge protection without any temporary edge protection at all. You also then have scaffoldless construction. You can install your windows from the inside, making it all extremely quick. And then obviously we have a really important fire detail and fire break detail that is then installed into a panel off-site in a very controlled and quality auditable way, which is perhaps a better system for approved inspectors and building control to sign off than might happen on site, where you can't be there watching somebody install it all day every day. And so we feel that this might have some real legs in being a solution. I know there are other solutions out there I've seen where people use a precast concrete facade instead of a steel facade, equally as good, and I'm sure there's merits in both of them. This was just one that was, this system particularly suited the building we were working on. But yeah, I think it's been quite an enjoyable experience to work through all the issues and try and find solutions as we go. One really big one was, I've got a picture of, I got one of these spider connectors delivered to the office, and it was huge, but it was the highest capacity one, I'm told, so that must be why. But one of the big issues, these are some images here from Rotherblast, are that it screws in from the top. So what happens is the vertical load from the columns transfer through this bar in the spider connector, but the loads from the slab are all picked up by these legs, which I suppose are the spider's legs, but I've not quite understood why there aren't 8 and there's only 6, but I'm sure I'll find out at some point. But yeah, the long Rotherblast screws that go into these screw head holes here pick up the load of the slab and transfer it back down into the columns, but they're installed from the top. So as you're laying down your slab, how are you safely installing it and without propping everything all the way up as you go, like you would in RC construction anyway, which would then mean it's no better. So the way we dealt with that was we designed the CLT slabs under construction loading to span on from the facade onto a temporary support or an internal wall line that would be decoupled later, so the CLT spanned quite a long distance in the temporary case, and then for its permanent loads and for the vibration and deflection cases, which usually govern your thickness of CLT, the columns then came into play, and we decoupled the temporary support wall, and that was designed to support it every 2 stories to keep the construction going as quickly as possible. So this isn't a solution that's been built yet, but it's just one that I think all designers out there at the moment who are used to working with CLT and fell in love with it, like the guys in Singapore did back in the early 2000s and 2010s. We're still trying to find ways of working with this that are safe, that people are comfortable in the UK doing, and will pass building control and insurance requirements. So yeah, I think there's probably lots of solutions out there, but I just wanted to share our working and thinking to date. And then my last tall timber project that I wanted to mention was the Beacon, which we worked with Nick Milestone and DRMM architects on. This was 24 24 meters high, and there will be another talk on this upcoming by DRMM and Shingi, who's an engineer on my team, on November 23rd. So thank you very much.
Okay, thank you very much, Kelly, and thank you very much, everybody. Andrew War has had to duck out, so I'm taking over to host the Q&A session at the end. We've got a few different questions coming in, but I'm just going to kick off there. We've seen some excellent projects from around the world, but it still seems that each building that goes up, when we're talking about tall buildings, timber construction is quite normalized in all parts of the globe on smaller buildings. But when it comes to bigger ones, when it comes to those bigger urban environments, we clearly can do it. We've seen some excellent examples there, but each building seems like a novelty, a one-off. And I just wanted to ask everyone on the panel, so Kelly, John and Nick, do you consider really now, we've focused on the sort of building challenges of building tall with timber, but is this an engineering challenge or is this a policy challenge? So I'll start with Nick Milestone, just to put you on the spot in a nice timber background you've got there.
You don't want to see all the people behind me here at the CTBUH conference in London. Yeah, you're spot on. You've got to look at sustainable markets. CLT has been the disruptor to the mass timber world. Blue Land's been kicking around since the 1950s, and it's just been nice to have. CLT has been part of the industrialization and digitalization journey that we're all experiencing now, and has been the disruptor. Putting that into context to answer your question, outside of Europe, North America is probably going to be, and is on the rise, as the most sustainable market for production at scale and volume and demand. So outside of North America and Europe, you will see spot projects. Singapore, I mean, it's a very small landmass, half the size of London. They all live tall. Concrete is the way forward. So there are always going to be spot projects. You'll see that in various parts of Southeast Asia. Australia is actually quite a sustained market, but unfortunately, it's only 23 million people living in 5 cities around the coast. Yeah. And that's a big landmass. So therefore, you look at the demographics of where it's affected. What I saw in my journey with North America is CLT being very much used as a floor play in office development, in residential development. But it's also, you go back to your question of timber policy. Let's look at France right now. They've got a timber first policy, and that's really effective. It's slowly moving behaviour. It's a small iterative step. New Zealand are doing the same. If you look at the work we've just done, David, and the rest of the team, in having that global manifesto, look how many people came to the party. Everybody wants it, but we know that it has to be top-down driven in order to make sustained economies using mass timber. Otherwise, we'll do one-offs, or we'll suffer a Grenfell Tower, unnecessarily kick the backside of mass timber unfairly, and we all felt the pain of that. But you know what? We adapt to building codes and regulations. The UK will play catch-up eventually, but I would suggest outside of Europe, North America, which is lagging about 12 years, will play that catch-up and become quite a big, big market. Starting to see that in Latin America as well as a potential sustained market. It's all about resource, availability of technology, capex, and policy. That's huge. Yeah. You know, it makes such an impact. And I think we've used COP26 as our leverage to put that in front of the politicians to go and say, climate change is real, stop using concrete, start using more timber. It makes sense.
Yeah.
That's kind of tried to sum it up.
Yeah, absolutely. Absolutely. Is there anything you want to add, either Kelly or John, on that particular question on?
I think I just add, it's definitely not an engineering problem.
Right. Yeah. I think that's.
I think there's always ways to engineer things.
Well, could I just add on that? All engineers in the UK pretty much train on steel and concrete, not timber, and so we do find that there isn't the same comfortableness that you guys are with steel and concrete. A lot of them with timber. Obviously, people like yourselves are, but that is something that does come out very much in projects, and often they're over engineered and so come out too expensive in timber. But yeah, as you know, so Nick was saying, there's lots of different factors. But I think in the UK it's very cultural. Great Fire London, Three Little Pigs. We're brought up from an early age to see timber as being a shoddy thing compared to good bricks and mortar, and it's, you know, it is a cultural change as well.
Yeah, absolutely. The Three Little Pigs was an early example of concrete propaganda, I think it was. But so I'm just gonna move along on a very similar note. We've got some questions coming in from people in the audience. One here from Andy Hain on the similar vein, actually. And he, John, you mentioned in your presentation that it was sad that the UK is, you know, used to be a front runner in timber construction, but seems to be moving slower. He said, how do the panel feel we can remove these biggest blockers, so insurance, building regs, and so on, preventing the increased uptake of timber? Should the government intervene?
Yeah, well, insurance is the big one, and really a lot of insurance companies taking a real hit from Grenfell, and so they're looking to reduce their risk, and they see combustible materials as the big thing. So really there needs to be a state insurance scheme, or maybe the big contractors or big house builders need to, as I believe they're looking into, get their own insurance to enable it, because that's the big problem people are getting unfairly. Because and I think also insurers, they have a lot of understanding about steel and concrete, but with timber buildings, they're tending to think if there's a fire in a timber building, they're putting it down as being having to be completely rebuilt, because they don't have that evidence of repair. So I think insurance is a good start.
I think, well, to sort of follow on from John, If we look at Gallagher's here in the UK and Gallagher's especially in the US, Gallagher's brokered the insurance for the Ascent Tower in Milwaukee with AXA. And because Gallagher's made such great efforts to prove that it's actually not a risk to build in wood, because it's actually designed for fire, it's predictable, and the size of the members were designed. Steel buildings, we have this obsession that steel buildings are safe. Steel buildings yield after 60 minutes to 2 hours. Doesn't matter how tall they go. It's just pure perception. Timber will last far longer in a fire than what a steel building would. Gallagher's have done great efforts, both UK with the Lourdes Foundation and in America, and they're talking to Lend-Lease. And what a difference that's making. It's giving people the confidence. So insurance is absolutely huge. When Grenfell happened and so many CLT buildings just converted back to timber, what for? Grenfell wasn't a timber building, but the insurance industry got skittish, and it was lobbied hard by the concrete industry unfairly. And that's the problem. People are more protective of profits and margins than they are about doing the right thing by sustainability. You know, it's human behavior for greed, unfortunately. It's a sad place, it really is.
Yeah, absolutely. Absolutely.
I was just going to add to that, if that's okay. I think the way through is education. So it's educating the insurance industry, which as Nick mentioned, the Lourdes Foundation and ASB are doing, and Gallagher's are doing a fantastic job of. But also education of engineers, as John alluded to earlier, which we're really...
Wasn't that a dig?
No, it's absolutely correct. And we have a university engagement committee at TDUK, which Tabitha Binding heads up, and that it's really encouraging actually, because I sit in those meetings as well, and most universities now want to get involved with it and start having much better resources, which we're starting to produce for them. And it is encouraging to know that it's definitely on the horizon. And a lot of the graduates that joined Whitby Wood this year did timber modules at university, which is probably one of the first times I've encountered that. So it is getting better. But yeah, I mean, also the government, they do need to step in as well, and with policies. But I think the will is out there from the market, from the developers, especially in the office market. There's, if you want to attract good tenants, in the next 10 years, they will be of a new generation that demands a higher quality of control over embodied carbon and carbon emissions of their buildings and workplaces. And developers are really understanding that now. They're really getting that. They also need to meet ESG targets for their funding. And so I think those drivers are also changing the market. Yeah, will change the market, but it would be much helped if government policy could get involved as well, which I know you're doing a lot of work to try and influence, Dave.
Yes, I know it's quite a tricky task, that. Just to stick on that, because it's one group, it's one audience that we don't touch on very often, is the clients themselves. So we often talk in the meetings we have about insurance. We talk about all of the different players, if you like, to make this building. So the architects, the engineers, the contractors, and so on. We don't talk much about the clients, as you've just mentioned, Kelly, and they are going to have to think about the people who occupy their building. What more can we do to kind of get to them? We talk about insurance and so on, but the actual people who are going to either commission a new building, commission the repurposing of an existing building, whatever. How do we get to them? Who are those people? How do we reach them? And is that possibly, when we talk about a top-down approach, we know that the designers exist and that the design is possible, that it can be engineered, that it can be manufactured and built. Do we need to influence that end customer as much as the government?
I would 100% say that. When I was involved in the Sky campus, 7 years ago now, that was a drive by Sky to the sustainable, to have a legacy, to be zero carbon, and they're stuck with it. We often find that we've got this part of the supply chain, the general contractor, who will look to dilute and save money. I was involved in a project as the financial crisis hits. London Fire Brigade were going to build 9 fire stations in Glulam because they believed in Glulam because it's predictable in a fire. And it was a statement by London Fire Brigade. The general contractor, who I'll not name, went in there and converted it into a steel building with deck and concrete because it saved money. And then we as the delivery contractor got blamed for that. And that is just totally wrong. And that's the game plan we have. You know, we need clients and stakeholders who are committed to sustainability and not just money. Because it's already been proven, the black and white building, which Kelly's going to visit, which is a great statement in itself, it's proven that clients will yield 15% more on their investment in a timber building, purely because of the visual aspect and the biophilic aspect. We don't measure that. We've never quantified the impact of biophilia and biophilic design. If we look at Google headquarters here in London, what a lovely building. Yes, 7 concrete cores, 1 massive steel frame, CLT floor decks. And it's there for sustainability targets. It's there because it's the right material in the right place. It challenges cost. It's the right hybrid solution. And therefore, they are committed to making that happen. And that's so important. And they will stand by that. But they engage with the correct supply chain. They engage with Lend-Lease to deliver it. Lend-Lease, we know how pragmatic Lend-Lease are in their sustainability targets, who've just done a big deal with Stora Enso. Yeah. And now, you know, without giving too much away, you know, I'm talking to Lend-Lease about the model that Kelly and I are working on together. That could go huge because they want to use CLT in the residential, but they have to respect changes in BS 9991. So we have to also make sure that we conform to building regulations as well. So going back to what you're saying, and I've gone off on 7 tangents there, clients have to stay committed to the cause and not let the general contractors dilute that offering that they want. The market's there, the supply chain's there. The supply chain now is in abundance and will grow in line with demand as well. We know that we've got more forests, legal and sustainable sourcing of material available to us that will ever supply will never sort of outstrip demand. Sorry, supply will outstrip demand, sorry, right way around. But it's just so, you know, with the infrastructure's there, that's what I'm saying.
No.
I think as well, built examples is how you attract clients to it. If there's something they can go and walk around and see how well it works, how beautiful it is, how healthy it feels as well, because that health is such a huge driver post-COVID, then that's how we get more of them involved. And I think they're also very driven by agents. So targeting the agents is another way to do it.
Yeah, to get through to them. Okay.
Also, trips over to our factories in Austria seem to be popular as well. Bit of Austrian hospitality, yeah. Yeah,
very, very good way to win people over.
It is.
I'm going to move on to some of the questions we've got here online from people. So there's a question from Shiva here who says, it's remarkable to see the way timber as a material adapts to tall building construction technology. Is it ever possible to also transform, and I'm going to get out of my depth here on my engineering knowledge, is it ever possible to also transform the vertical shear walls with CLT and not decouple them to retain them as service cores for tall buildings? That's quite a question, isn't it?
That's one for Kelly, is that one?
Thanks, Nick. I think the as I understand that question, we're asking, can you use CLT as shear walls, like you would an RC core and an RC shear wall? And you absolutely can, yes. I've designed several buildings that have CLT shear walls and a frame around it. There's very close. You've got to think in a lot of detail about the floor diaphragms and how CLT floors can transfer the wind loads back to those cores, and the connection of the diaphragm floors to those cores, because that's more flexible than it would be in an RC construction, and it needs a lot of thinking about, and probably a lot of screws, probably not 1.1 million screws, but more than you might think. So but yeah, it can be done, and I think that was, hopefully that answered the question, unless I misunderstood it.
Yeah, that gets my vote, certainly. But I'll defer to that. I have no idea on those subjects. We've got a couple of questions in here now, and really on the same subject, saying that, you know, there are a lot of forecasts which show that global demand for timber is set to triple by 2050. We know that we've had problems in the supply chain over the past year or two with COVID and the pandemic and logistics and so on. Do you think we'll face a timber shortage in the short or long term? And how will the supply be met? Any views?
I don't think, yeah, it's not just timber, it's steel and concrete as well. You know, when COVID impacted, everybody shut down. It's quite simple, demand dropped. Now demand's not just picked up, but concertinaed from the stuff that should have happened with stuff that's happening already, has put sort of major pressure on timber, steel and concrete, all raw materials. We're no different to the semiconductor market. Going forward for the long-term sustainability, John alluded to it earlier on, they've got a small window of opportunity in the North American market before North America switches on, you know, its glulam and CLT production lines, forcing the Europeans out. And you'll see that more and more. Supply is there. So long as demand comes, then supply will deliver that demand. I think we outstrip, 2-3 times currently what demand is. Don't forget, timber's using a variety of other products, paper pulp. You know, mass timber is such a small segment. It's such a small segment in the reality of, you know, the need for timber. We'll be fine. The beauty of wood, without sounding like a tree hugger, you know, we take steel from the ground with iron ore, take cement from the ground and concrete. Timber grows. It's a naturally reproduced product. So long as it's from legal and sustainable sources, then we're fine. You know, we are replanting the trees sufficient enough to cope with demand. It's the bad things we see on TV. Like at COP26, I saw about stop deforestation in Latin America, and rightfully so. And it's only because that's just illegal logging, because there's no legal and sustainable infrastructure in place. We're pretty blessed here in Europe and in North America by have been regulated by both FSC and PEFC. All of John's materials from VHAG, all the materials we use on the NTU in Singapore, were all 100% PEFC certified. So they came from legal and sustainable sources. And this is why it's so important that we maintain that. Clients can look toward cheaper alternatives, you know, Russia, China, Latin America, but that is not sustainable. We have to stay strong on the legality of where the material comes from. And I know, David, it's very passionate and true to your heart, is that?
Yeah, it is. It is something we've...
Not just from a softwood perspective, from a hardwood and a tropical timber perspective as well.
Yeah, we've been doing a lot of work on this, and we have launched a whole initiative called Global Forests Need Global Governance. And it is true to say, well, several things. First of all is, actually in Europe, we've got strong laws, strong regulations, and the forests are growing. So they've grown about 10% since 1990, while at the same time, the industry has grown the volume of output, we've grown the value of output, and so on. In North America, the same thing there. I can't remember the actual figures, but the forests have grown whilst the volume of timber being produced and being used has grown, and the area of forests has also grown. And that's not true in the tropics, and it's largely down to a lack of sort of legal infrastructure and a legal governance over land use and so on. So it is something that we're very keen to promote as an industry is legal and sustainable supply chains. We also have an event, and I haven't got the date in front of me, but if you look on the World of Wood website or on ttf.co.uk, we've got an event coming up either next week or the week after about saying where will our wood come from, and do we have a sustainable supply? And we've got speakers from the UK, from Europe, North America, and the tropics to talk about that and say, will we have enough wood to meet demand over the coming years? So please do have a look at that. I'm just going to have a look to see if there's any other final, some links there in the chat function to the list of events that are coming up, and you can tune in for those to hear people talk about that. So I think unless we have any further questions from the audience, please do keep your eyes peeled for future events that are coming through. We've got a lot of another session, I think, next week about decarbonising cities. This was the first one about decarbonising cities on building tool with timber. Next week, they're going to go into a bit more detail on the barriers and solutions, particularly the policy solutions around insurance and fire and so on. This week, though, I think we've made it quite clear that around the world that it's not an engineering problem. Certainly the engineering solutions exist, the know-how exists, and the wherewithal exists to build them, but we do need a bit of support to make this a not just mass timber, but mass market solution. So thank you very much to Kelly, John and Nick, and to Andrew earlier. Thank you for everyone for tuning in, and please do look through all the resources on the World of Wood website and join us again next week for the next session. Thank you very much.